Assalamualaikum warahmatullahi wabarakatuh. It's me again with Hess Law now. Hess Law, different to the previous one, which is bond enthalpy. In Hess Law, to find the enthalpy, there are three types of calculation using Hess Law. We have learned 1 and 2, and we will learn the third one next week. So the first one is energy level cycle or energy level diagram. This is cycle. I forgot to write here. So in energy level cycle, please make sure you notice the arrow. So in here, it's like you're going to one place, you have a straight way, but then you decided to turn around and go somewhere else first. So this is the reactant. This is the reactant, which is A plus, usually it's a reaction, but this one is to make you understand the concept simpler. So here is the reactant, and this is the final product. So on the way from reactant to product, this reaction goes to C first and then to D first. When A becomes C, they have their own enthalpy. From C to D, another enthalpy. From D to B, another enthalpy. However, all of this combined will become from A to B. So basically, it's like where you using energy from A to B by running, with A to C to D and B by walking, you will be using the same amount of energy. Here, delta H will be delta H1 plus delta H2 plus delta H3. Then, if you are being asked of delta H2, for example, let's say the question asks delta H2, which is the reaction from C to D. So all you have to do is doing a math. Everything will be moved to the other side. So delta H2 will be delta H minus delta H1 minus delta H3, because this one all moves here. Same way with finding delta H3. Now, on the way, sometimes you have different arrows, which mean instead of going from A to C, you are given the enthalpy of C to A. However, to create a reaction from A to B, you have to go from A to C, C to D, and then D to B, not the other way around from C to A, unless the reaction is from B to A. That can also happen. So if it's like this one, you need to turn the arrow on the right path. So wherever you have here, minus or plus, you have to do the reverse one. So now it becomes minus delta H1, because I assume this is going to be plus. Then this one is also wrong arrow, so you need to make it the correct arrow. So this will be minus delta H3. So to find delta H, you will have minus delta H1 plus delta H2 and minus delta H3. Okay, I hope you understand the concept that basically you are going from reactant to product. Wherever trip you have to go from A to B, make sure you are following the right track. If you are given the wrong energy, correct the energy by making it minus, by making the opposite. So here is an example. The reaction is calcium carbonate become calcium oxide, and carbon dioxide. How many enthalpy does it need for this reaction? Or need or release? I don't know how much energy being released or being needed. Now we have this one, so this is the questions. So as you can see, from A, so this is A, because this is the reaction, to B, and has to pass through C. From A to B is delta H. Now, from A to C, as you can see, it goes the other way around. the questions or the problem is giving you wrong delta H or wrong enthalpy. So you need to fix it by fixing the arrow, which then fixing the enthalpy become plus 200 kilojoule per mole. This one is the same direction, so you don't have to change it. So delta H will be this 200 kilojoule per mole plus minus 100 kilojoule per mole. So this comes from here and this one from here. So the final delta H or the final enthalpy will be 100 kilojoule per mole. This is an endothermic reaction. Okay, easy, right? You just need to follow everything. Sometimes you are given a diagram instead of a cycle. It has the same principle. So this is the diagram. So this is the reaction, which is reactant, and this is the product. And this is the reaction or the elements that they have to pass through to get here. So instead of a cycle, it becomes a diagram, but with the same concept. Now look at it here. When you are needing to find delta H, it's also the same, equals delta H1 plus delta H2. If the arrow is in a reverse, then you have to make it into a reverse too, like plus become minus or minus become plus. The question is not always delta H. Sometimes we are questioning delta H1. So this is an example. Let's say delta H is, I'm going to use other color here because as an example. Let's say this delta H is a burning process, so minus 100 kilojoule per mole. Then you are also given this part, which is minus 20. No, not, I don't think it's 20. Will be, let's say 56 kilojoule per mole. So how much is this? Using the same formula, delta H equals delta H1 plus delta H2. So you will put minus 100 here, equal delta H1, the one that we are questioning here, plus minus 56. Unless the arrow on reverse, then you have to change that. If not, then you just follow the given enthalpy. Now delta H1 will be minus 100, plus and minus become minus, but then when it moves to the other side become plus 56. So you will have minus 44 kilojoule per mole. That one goes here. Okay, that one is the energy level diagram or cycle. The second part is a bit similar to bond enthalpy, but be careful with this one. When the enthalpy with the bond enthalpy is reactant minus product, but for this one it's product minus reactant. People often mistaken these two parts when they're doing the task. So be careful with it. And then important note is that elements and diatomic compound has no, it's supposed to be have no enthalpy formation. Why it has no enthalpy formation? Because they're already there. You do not form them. This formation are only for compound, because compound is formed from so many elements. Now let's see this one. This is the question, the reaction. Methane plus water become carbon monoxide plus hydrogen. This is already being balanced. Remember, before you continue to calculate, you need to balance them first. And delta formation for CH4 is minus 74.8, and for water is minus 286. For carbon monoxide is minus 111. This one we do not give it because the delta formation is 0 kilojoule per mole. Hydrogen is already there in the nature. Now, before we use the formula, you can break them down first if it has a coefficient. So because it doesn't have coefficient, you just note it down here. We have 1 CH4, 1 methane, which is minus 748, minus 74.8. Then we have 1 water, minus 286. You add them together, and then in this part we have carbon monoxide, which is minus 111. So minus 74.8 plus 286 will be 360.8. Now delta H or enthalpy will be of product minus delta H of reactant. The reactant is this one. The product is this one, and the reactant is this one. So minus 111 minus 360.8. So remember, minus and minus will become plus. So you will have plus 249.8 kilojoule per mole. This is an endothermic reaction. So, okay, that's the result. So if you have any more questions, feel free to ask me, and see you next week. Wassalamualaikum warahmatullahi wabarakatuh.